Okay, one of the things that you are being asked to do in your midterm is to create frequency tables, histograms, relative frequency histograms. You're going to be asked to do scatter diagrams and scatter diagrams with best fit lines. And because the exam is multiple choice, you need to be able to create these tables and diagrams because you are going to have to match them to the correct answer. So what we're going to do right now, we're going to go ahead and we are going to go through a tutorial on how to do a frequency table in Excel, how to do a histogram, how to do a relative frequency histogram, and how to do a scatter diagram and a scatter diagram with the best fit line. So let's go ahead, and what I did is I used a data set with XY values so I can use it to do double duty. So we're going to do our frequency table using the number of visits per week, and we're going to construct this table with class limits, class boundaries. We're going to have midpoints, frequencies, relative frequencies, cumulative frequencies. And this particular frequency table is going to have 3 classes. And if we need to, we're going to round our answers for the relative frequencies to the nearest 100, which is to 2 decimal places, and the midpoints to the nearest 10th, which is 1 decimal place. Now, before we can do anything, what we got to do is we have to compute our class width here. Now, our class width, CW, is just our maximum value minus the minimum value, that difference divided by the number of classes. Well, our maximum value is 29, our minimum value is 5. We have 3 classes in our frequency table, and when we do that division, we get 8. Now, one of the things that you keep in mind is that it does not matter whether it's a whole number or a decimal number, you always round it to the nearest whole number. Because if you don't, you're not going to have enough bins for your data. And you have to have enough bins for all the data to fit into. So here, what I did is I started with my lowest value. So we start with our lowest class limits first. So I start with my lowest value, which is 5. And then my class width is 9. So if I add 9 to 5, I get 14. If I add 9 to 14, I get 23. So I've taken care of my lowest class limits. Now I go to my upper class limits. Now upper class limits never overlap. So to get the upper class limit of the first class, I look at the lower class limit of the second class. I see it's 14, so this is going to have to be 13. To get the upper class limit of the second class, I go to the lower class limit of the third class. I see it's 23, so this has to be 22. Notice if I add 9 to 13, I get 22. And if I add 9 to 22, I get 31. So my lower class limit in my first class is 5. My upper class limit in my third class is 31. The highest value in the data set's 29, so we've got enough buckets to put all of our data in. The next thing that we do is we compute our class boundaries. Now, class boundaries for whole numbers will always be 0.5 less for the lower class boundary and 0.5 more for the upper class boundary. So my lower class boundary in my first class is 5. So 0.5 less is going to be 4.5. My upper class limit in my first class is 13, so my upper class boundary is going to be 0.5 more, so that's 13.5. My lower class limit in my second class is 14. My lower class boundary in my second class will be 13.5. That's 0.5 less. And for my upper class limit is 22. 0.5 more is going to be 22.5. Also notice that if I add 9 to here, I get 22.5. If I add 9 to 22.5, I get 31.5. So I've got all of my class limits and my class boundaries. Now I just need to get everything else that I need. And to do that, what I'm going to do is I'm going to go over here. I'm going to click in here, and then I'm going to say data. I'm going to do data analysis. I'm going to hit histogram. I'm going to click OK. And what you're going to do here is you would highlight the data that you want to do the histogram for. So here it's going to be A2 through A16. Then click here. I'm going to go back to my table. My bin range, if you remember from your Excel lab, is going to be your upper class boundaries, and that's L2 to L4. I don't check labels because we're not using any of the labels. My output range, in other words, where I want them to put the table at, it's going to start in M1, and I want to do a histogram, so I click the chart output button, and then I just click OK. Now notice, I'm going to bring this over here, notice that my bin here doesn't do anything but just repeat my upper class boundaries. And notice that I have this more and 0. Well, I don't really need that, so I'm just going to go over here, highlight it. I'm going to go to home. I'm going to go over to clear, and I'm just going to just click clear all. Get that out of there, and then here I'm going to click on this legend. I'm going to hit my delete key, and now on the test, these are going to be labeled, and this you might see an F instead of the word frequency. This, if we wanted to put a label here, would be the number of visits per week. But what you would do is you would look at this histogram and look at these frequencies for the ones that you have to do a histogram for, and you want to see, does the histogram that you've created match the one in the test? If it does, and if you've done everything correctly, then you've got the right answer. Now let's go ahead and let's put this over here out of the picture for a minute, and let's finish off our table. Now it says class limits, class boundaries. We need to do midpoints. Well, the midpoints is just basically the average of your upper and lower class limits. So what I can do here, if I take 5 plus 13, that's going to give me 18. 18 divided by 2, that's going to give me 9. If I take 14 plus 22, that's going to give me 36. 36 divided by 2 is going to be 18. And if I do 23 plus 31, that's going to give me 54. 54 divided by 2, that's going to give me 27. So I have my midpoints there. Now, the next thing I need to compute are my relative frequencies. Well, I've got my frequencies. Now I need my relative frequencies. And to compute your relative frequencies, let's expand this a little more. What you do is notice that if you sum up the frequencies, that's going to be how many data points you have in your data set. Well, if we count here, we've got 15 data points here. So this is going to total up to 15. Well, to get the relative frequency, I just take my frequency, which is 5. I divide it by the total in my data set, which is 15. And that's going to give me my relative frequency. Now what I can do, instead of going through, I can just go ahead and drag that down. Oops. I shouldn't have dragged that down. And I can just go ahead and do 3 divided by 15. And then I get what I needed. So in order to get the relative frequency, you take the frequency and you divide it by the number of observations you have in your data set. And that is going to give you your relative frequencies. Now here in our problem it says to round the relative frequencies to the nearest hundred. Well, what I can do is I can come up here, and do you see this? Where you decrease the decimal, the nearest hundred is going to be the 2 decimal places. So I just go ahead, take that down to 2 decimal places, take this down to 2 decimal places, bump this up to 2 decimal places, and there I have my relative frequencies. Then it asks for cumulative frequency. Well, and I'm just going to go ahead and stretch this out, giving myself a little bit more room. To get the cumulative frequency, what I'm going to do is I'm going to start with my frequency here. And my frequency in my first class is 5. And then what I'm going to do is I'm going to add to that one, because for each class the frequency is going to accumulate. So if I have a frequency of 7 here and I add it to my 5, then I've got a frequency of 12. And if I take my frequency of 3 here and I add it to my 12, I get 15. Okay, so, and I'm just going to go ahead and I'm going to center this and center these as well. This one. Okay, so I have essentially created my frequency table, and if I kind of sort of move that bin over, I have everything that it asked for. I have my lower class and my upper class limits. I have my lower class, my upper class boundaries, my frequency, my midpoint, my relative frequency, and my cumulative frequency. Now when we did the when we initially did this, we already got our histogram. Now, if we wanted to create a histogram for our relative frequencies, then what we would need to do is we would need to highlight our upper class boundaries again, and we would need to highlight our relative frequencies. So you're going to hold down your control key and your mouse, and then you've got both of those highlighted. So now what we're going to do is we're going to come up to Insert. We're going to go over here to where it says Column, and we're going to insert a 2D column. Now what you're going to notice about this is you're going to have 2 series. You've got this blue series here, and then you've got a series 2 here with the gold bars, and then you've got another series stuck in there. So I think somewhere I probably over highlighted, but what you're going to do is you're going to go to Select Data, and what you are going to want to do is you're going to want to remove the series 1, because if you look at the series 1, they're all whole numbers, and our relative frequency, the Y values, are decimals. So you want to remove series 1, and you want to also remove series 3. So we're going to remove that. And then you're going to want to come over here, and where it says 1, 2, 3, what you want to do is you want to click Edit, and you want to just highlight your upper class boundaries, then click OK. Let's get rid of this legend, and here we have our relative frequency histogram. And the other thing is, when you start looking at chart titles, the chart title over here is going to read F over N. So let's go over here. Let's do format. Do I want format? Let's do here quick layout. And yeah, let's go ahead and do that. And over here, your axis title is actually going to read F divided by N. And then here it's going to read whatever the title of the boundaries is. Here, this is number of visits per week. And we don't really need our legend there. But in any case, the gist of it is that when you do your graphs, you want to compare the graph that you create to the graph that they give you in the multiple choice STEM. And if you've done everything correctly, you should find the graph that you've created there. Again, you have a week to complete the exam. So what I would do is I would work through the ones that I know how to do first, the ones that are going to be challenging a little bit, or that might require a little bit more work, but I still know what I'm doing. I would do those next, and then the ones that I really don't understand, I would save those for last. So that's how I would break it up. But in any case, when they ask you to do the frequency table, the histogram, and the relative frequency histogram, this is what you want to do, okay? Now, let's go ahead and let's look at what we would need to do when we're doing our scatter diagram. Okay, so in a couple of the problems, you're going to be asked to do scatter diagrams. And to do a scatter diagram, you just need to come over, first go to Insert, then go to Charts, then go to Scatter. And notice here, it just created a scatter diagram for you. Now you want to check to make sure that the points are right. So for example, we have an X value of 5 and a Y value of 2. Well, that corresponds to here. Then about here you've got an X value of, as a matter of fact, it tells you right there, that corresponds to the point 0.73, and the point 0.73 is right there. So we know that our chart's correct. Again, if we wanted to label it, our x-axis would be, as a matter of fact, we can go over to add chart element. Our x-axis would be, if we were actually doing this for an assignment, again, for your midterm, all you're doing is picking out the correct graph for the problem. And then we just do add chart element here. And here we've got the number of individuals purchasing insurance. And if we wanted to, we can just go ahead up here and we can talk about insurance sales. Based on number, type number of visits per week. So now we've got a nice little title for our graph. Now let's go ahead and let's talk about, I went ahead and dropped it in, but let's talk about how to do this thing here, this trend line. So what I want to do is I want to click on my data points. I want to right click here and it's going to say add trend line. So I just click here. It's going to give me trend line options. I'm going to pick linear. And for kicks, grins, and giggles, I'm going to say, let's display the equation and then let's display the R squared. So we've got that information on the chart. Now you don't have to do this for the midterm, but I just thought it would be interesting. This r squared is called the coefficient of determination. And if I take the square root of the coefficient of determination, I will get the correlation coefficient, okay? So, I got a couple of emails where people were saying, well, hey, we don't know what the r squared is. What does that mean? Well, that was in section 4.2, and that's the coefficient of determination, the r squared is. And if you take the square root of that, you will get the correlation coefficient. So the other part that's really interesting is if you go up to, let me move this up a little bit. If you go up to data and you go to data analysis and you again click on regression and you click OK, notice you will get a regression menu. Well, it asks for your input Y range. Well, you just highlight your Y values. And then it will ask for your X range, and you just go ahead and you highlight your X values. And then it will ask you if you're using labels, confidence intervals, do you want them? We're not using them, so I'm not going to check them. We're not going to use labels. But then it will ask you for an output range. And notice that our output range is here in M1. And I just want to get this table. Okay, so somewhere I've done something quirky. This is what I've done. What was that? X values. So my X values need to be the same. So all kinds of things can go wrong when you're doing this, but let's try it again, see what we get. Aha. So notice we get this table here, and let me kind of stretch it out so that you can see what you get. Notice this value is this value here. Notice it tells you the number of observations. And when you had to do your regression equation, you had to determine what is A, what is B. Well, all that's given to you in this table. And while I'm not going to go into everything about this table, I just wanted to show you that you can get that output, and we'll be looking at it a little bit later on in the course. But for now, we'll just go ahead with these two little gems right here. But I just wanted to show you that if you check the regression option, you can get a lot more information, which basically doesn't mean anything to you right now, but it will as we get into the later chapters. So with all of that being said, there is one more thing that we need to look at. And the other thing that we need to look at is when it comes down to if there are outliers within the data set. Now, what I'm going to do, I'm going to go back to my X values here, right here. And basically what it says is that if you look at 2.5 standard deviations to the left and 2.5 standard deviations to the right, then what you're going to find is anything outside of that range. So let's say if we looked here, let's say our mean is going to be 16.5. So our mean here is 16.5. This is our mean. And if I wanted to get my standard deviation, then I could do standard deviation of a sample. And then I just go ahead, click that. And then I get my standard deviation for the sample. So here's my standard deviation here. Now, if I did 16.5 minus 2.5 times this value here. Then I'm going to get negative 0.186. And then if I did 16.5 plus 2.5 times this value here, well, it always helps to put an equal sign in when you're trying to do calculations. So this value here, and then I hit enter. Notice I get a range of values, the lowest value being negative 1.9 and the highest being 34.9. Notice that all of our values from low to high fit within that range. And if all of the values fit within that range, then you have no outliers. However, if we had values that were outside of this range, let's say, for example, we had a value for x that was, say, 36. Well, 36 is outside of this range that we've been given, so 36 would be an outlier. So anything that falls outside of the range from low to high is going to be your outlier. So again, I hope that this helps, and I wish all of you the best of success with the exam.